Oh, she's almost fell. Today we are learning about not liking and subscribing, although I'm supposed to say like, subscribe, ring the bell, I don't know, all that stuff. But today we're learning about our third favorite thing in math. Ta-ta! Exponents. Yeah, exponents. Exponents are a fun little way in which we can multiply things much faster, or we write multiplication faster. So, for those who don't know, multiplication is what we call fast addition, right? That's all multiplication is. So if you say 3 times 3, that's like, well, 3 plus 3 plus 3, right? So you say it's 9. Multiplication becomes fast addition. Exponents becomes fast multiplication. Rather than us writing 3 times 3 times 3 times 3, we can write 3 to the power of 4 or 3 to the exponent 4. And we're going to go through and we're going to explain a little bit about that. Remember, mathematicians are lazy. That's okay. They don't want to have to write out 3 times 3 times 3 times 3 times 3. Instead, they can write 3 to the power of 4. When we look at an exponent, it's made up of 2 parts. What we call the base, the big number. That's the base or the number that's going to be multiplied by itself. Okay? The exponent, or what we sometimes call a power, we might say to the power of, we might say 3 to the power of 4. The exponent becomes 4, okay? And what that means is that's telling us how many times the base becomes multiplied by itself. So if we see something here that says 3 to the power of 4 or 3 to the 4, it looks like this. 3 is what's multiplied. By itself 4 times. So there's 1, 2, 3, 4s, but they're being multiplied by themselves. Okay? And I know in your mind you're like, well, there's 4 of them, so it's got to be 12. But that's not how this works. 3 times 3 times 3 times 3 is not 12. 3 times 4 is 12. But this is 3 times 3. What is 3 times 3? 9. Now you take that answer and you multiply it by 3. What's 9 times 3?
27.
It's 27. Now you take this answer here and you multiply that by 3. What's 27 times 3? 81. And it becomes 81. Okay? So when we talk about exponents, we talk about a base, we talk about an exponent. Together, the whole thing is referred to as a power. But sometimes we'll say 3 to the power of 4, or 5 to the power of 3, or 6 to the power of 7, right? We always say the base first, 3 to the power of 4. And this is how exponents work. So there's different ways. We talk about exponent form, right? So we say 3 to the power of 4. It's written as an exponent, okay? It can be written as expanded form. Three times 3 times 3 times 3. And finally, it can be written in standard form. Standard form is the answer. Okay? So you have exponent form, expanded form, and standard form. Okay? If I was to write, say, let's say 5 to the power of 3. Okay? We're going to write 5 to the power of 3. Who can tell me what the base is in this exponent? What's the base, Cruz?
5 3 times.
So 5 is the base. It's going to be multiplied by itself 3 times. The exponent is 3. If we were to write this in expanded form, what would it look like?
5 times 5. 5 times 5.
Like that. What would this look like in standard form?
I have no idea. You have to do math.
Well, what is 5 times 5?
25. 1,
That's 25. So then what is 5 25s?
125. Yeah, 100.
So this is what we're dealing with when we deal with exponents. Last thing, whenever you're dealing with specific exponents, something like, let's say, 6 to the power of 2. Okay? Sometimes people just use special language whenever something is to the power of 2. They would say 6 squared. 6 squared, right? That means the base times itself twice, and it equals, we know, 36. 6 squared, or 6 to the power of 2. The other one that we sometimes talk about, which is a little bit different, well, we just had it up here already, but if we were to continue with the same example, right? Sometimes they'll say 5 cubed. Cubed. Right? 5 to the power of 3 is also sometimes referred to as 5 cubed. And we know already because we put it down. 5 times 5 times 5, it equals 125. So, exponents aren't super difficult, but they can be a little bit tricky sometimes. Okay? So you have to understand what the base is, what the exponent is, and how they work. Lots of times, one of the biggest mistakes for 7-8 students, when they're looking at this, they just think to themselves, oh, it's 5 times 3, so I know the answer is going to be 15. Right? Or they might look and say, oh, 6 times 2, I know the answer is going to be 12. But we know it's just multiplying by the base the number of times the exponent tells us to, right? We don't multiply these two numbers. We multiply the base by itself this number of times. Does that make sense to anyone?
Yes.
Does anyone have any questions? Yep.
So for the 6 one,
Yep.
so we do 6 times 6 and then times that by 6?
No.
It's just 6 times 6.
It's just 6 times 6. It's just 6 squared. It's just 2 6s. 6 times 6, and that's the answer. 36.
Wouldn't it be 12 then?
No, because 6 times 6,
Not 6 plus 6.
Oh.
it's 6 times, right? We multiply it. You have to multiply it, right? I know in our minds we're thinking, oh, 6 times 2 or 2 6s. But it's not 2 6s, it's 2 6s multiplied by each other. Okay? Same thing here. It's not 3 5s, like we add them up, 5 and 5 and 5. It's 3 5s multiplied by each other. And then we multiply the sum of the first two by the next one. So we'd go 5 times 5 is 25. Then we'd take our 25 and we'd multiply it by 5. Then we could take this, if we wanted to throw on another one, times 5. Now we're taking 125 and multiplying it by 5. Right? We've got 100, 200, 300, 400, 500, 625 is what we're looking at, right? Once we multiply by 5.
Are we allowed to use our calculator?
Yes, you are allowed to use your calculator. And we're going to talk tomorrow about using exponent buttons on calculators. But today, we're not going to do that, okay? We are going to do some really fairly basic exponent questions today, just to get us used to this idea. Any other questions before we move on? All right, like, subscribe, ring that bell.